Okay. Okay. I think you can all hear me. And can the screen, the live stream, see me too? Yeah. Yeah. Okay.
You're not sharing anything.
Oh, I'm sharing. Oh, sorry, not sharing on the live stream. Okay, sorry. Let me, let me go back here and share. Where is my thing? This one. Am I sharing on the Zoom? Okay, awesome. Thank you. Thank you, everybody. Thank you for coming out today and coming to our meetup, AI Collective Chicago chapter. Today, we're very happy. This is brought to us by Vectorize, by Chris Latimer. He's the CEO of Vectorize, and they are doing amazing things with AI agents, memory system, and that's what you're here for. And he's going to go do some deep dive, but very palatable for all of us, too. So that's the thing we're doing today, although let me kind of get rid of that, and okay. I think you can see it anyway. So, okay, so this is... How do I close it? Stop share? I can't close it.
On the top, there's a...
I can't, oh, here we go. I can't tell it to close. How do I close?
The thing went up, actually. So stop sharing and reshare, then that box will come down, hopefully. And
okay.
You can close it. Yeah.
Okay, sorry. Let me do it again. This way.
Yeah, sure.
But see this thing.
Way up there.
Yeah, because.
Yeah, you can drag it down.
Drag it down, yeah, okay, sorry. Okay.
Not that.
Okay, this one's fine, but the other one, oh, here we go. That's fine. I minimize, okay. Thank you. It's always something, yeah, okay.
Close this as well, the three dots.
The three dots, oh, okay. Hide, hide, floating. Okay, all right, I think we're good. All right, just a little bit is not blocking. So, okay, thanks again coming to AI Agents Technical Talk and Demo Night. So we are going to have this particular agenda for tonight. We already finished eating pizza. Actually, you can continue to eat. I think we have plenty. I ordered like 38 boxes of pizza because there are like 152 of you signed up. I don't know. I think it's maybe like 60 or 70, maybe 50, 60. So this is still a good number. So thank you very much. So we'll just do some quick housekeeping, nothing too much, and then we'll have a word from our sponsor too during this time. And then of course I also didn't say we're going to have two presentations tonight. We'll have Chris Latimer from Vectorize talking about Hindsight, their new AI agent memory system, and then some Q&A. And after that we'll have Aaron from IBM doing a demo of an IBM weather NWS National Weather Service app too. So that will be fun to follow along. And then after that, we can have more social networking. There's some cookies here too behind you. So then you can stay awake with more sugar. Yeah, so that's full of intention. And also wanting to mention that we'd like to encourage you to ask questions. So if anybody would be asking a question, we have about like 10 or 12 AI agents books that we got from Comash, and it's actually from a company. I forgot exactly the name of that company. Yeah, they do AI agents too, but they are a Y Combinator startup company. So and over here, so they have a book about principles of building AI agents, and another one talking about patterns too. Oops. Okay, so yes, so when it comes to Q&A, we'll be giving out 12 books. So just remember, have some questions to ask, and you can get one of the books. And then after that, yeah, we can have more social networking. But before we start, we want to thank you again to Microsoft Chicago for the venue. We always have it. And then Mr. David Giard is here, and thank you so much. He's always been a very, very great community supporter, so that's very nice. So thank you so much, and we'll have a few words from David and about Microsoft as well.
Thank you. I'm not going to talk about Microsoft. I do work for Microsoft. My name is David, but I do want to say thanks for coming out, supporting the community here, giving up your evening. I think it's great. We went for a couple of years with very little community involvement, and I wanted to just call your attention to some more events that are coming up that I'm involved in, which I made a slide. There were enough of that. I was going to write them on the board, and I wrote one of them there, ChicagoCloudUG.com. That's a group that my friend Eric and I run. We are having a meeting next week on Tuesday evening. I need to share it. I don't know how to do that. I'll have to just tell it. I'll send you the slides. You can put it in there. So Tuesday evening, we're going to have a talk. It's on building data pipelines in AWS. All these groups are here in this room right here in the Microsoft office. AWS is the Microsoft office. This is just us talking here. And then in a couple of weeks, on March 11th, we'll have one using about the Sovereign Cloud. Sovereign Cloud is a brand new product running Azure cloud computing on premises. It's become a big deal as regulations are, people are worried about governments coming in and actually requesting companies like Google and Microsoft and Amazon to hand over their data. Well, they want to keep their data closer to hand, and Sovereign Cloud released actually next week, so it'll be a really timely topic. A project manager on that team will be speaking at that. We also have a brand new group, the Microsoft Foundry meetup. Foundry is Microsoft's one-stop kind of Swiss Army knife where all the AI tools are being put into one spot there. And the very first meeting will be on Tuesday, March 3rd. We'll have 2 speakers there. One of them will be me. That'll be here in the evening. And the last one I want to call attention to is the Global Azure, which is an annual event that takes place all over the world on the same weekend, and ours will be on Friday, April 17th. Starts at 9 o'clock in the morning. It'll go all day. We'll have multiple speakers talking about cloud computing. Some of it will be tooling, some of it will be case studies, just all sorts of good information. If you're interested in cloud computing, that's a great event. That, if you go, you can get general information at globalazure.net. We haven't put up the local Chicago site yet. But the other ones, you can click on those links or go to those links. I'll try to get them to around so we can share them and register just like this event. You want to get registered, so one, it gets you in the building a lot faster through the building security, and 2, we can order enough food for everyone, which is really important. That's about all I have to say, except that this would be an excellent time for everyone to silence your cell phones. Thanks a lot.
Thank you. Thank you, David. Thank you so much. Okay. Okay. Is it? Oh, that's not coming up. Or, Okay. All right. Good. Thank you. Okay, so now just a small few seconds too about what is AI Collective. So it's a grassroots nonprofit organization that started out in San Francisco, and now we have expanded worldwide. And as you can see, we have like 207,000 plus members now. All these like kind of just stats. So I won't kind of like spend all the time talking about it, but collectively, we've hosted like 1,000 plus events. And if you're in San Francisco, you'll be in for a treat because they have things running every night. And yeah, that's just pretty amazing. I was there too. So yeah, so it's a very vibrant group, and it's not just about technology, even though technology is driving all of this AI, but they're also investors and startup founders, product people, education, responsible AI folks, AI ethics, all these, you can name it, anything to do with AI. We want to collectively bring people together and really make AI more of a human-centered type of thing rather than, something that will overpower us. So, yeah, so if you're interested, if you have any suggestions, you want to see something or see some speakers or have some events, and we're doing hackathons. And by the way, I'll be telling you we have more events coming. Let us know. We'll be very happy to take any input you have, and we'll try to do as much as we can to serve the community. Because for myself, I really want to make Chicago more, vibrant too, right? It's not quite like SF, but would be nice, right? Just all the activities, all the stuff that's going on. So I think it will be great. So that's that. And then as you can see on this map, we have it actually the very north of us. We're like up to Thunder Bay in Canada for America. And then South America, we also have Brazil too, right now, where we're expanding. And then also in Europe too, we actually have Sweden too. The chapter's up in Sweden, and we're starting in Finland and Norway as well. And then in the south too, there's also Cape Town. That's a very south in Africa. And then also, as you can see in New Zealand too, we also have a chapter as well. So as you can see, it's just growing like crazy right now. And what this means for you, that means we want to bring more and more people together. We want to make this a very safe environment to talk about AI or anything else to do with AI. So it should be good. And so we invite you to join the community. You can go to our website, aicollective.com. And then if you want to join, and again, any suggestions, you're welcome to send emails or reach out to us too. Oops, and then tonight's live stream, for those of you already on the live stream, you're watching it, but otherwise too, if folks are interested, you can tell your friends. You can go to the open-development, and that's Ron's help. So thank you so much to Ron Arunava. He and I met at IBM before, so Ron is also very active community organizer as well. So. And here, just a quick introduction. We have Jonathan here tonight. He's the head of Chicago chapter in there. Yes, thank you. And then these are the different folks who are on the leadership team and volunteer team as well. I'm trying to kind of take a look. A couple of people join us too over the holidays. So we have Yukta here, and also Sogo and Brett too. So yeah, so if you have any questions, you can reach out to any of us tonight. Okay, so some upcoming events. In March, it's International Women's Day. So Jonathan has very graciously opened up his house again. Last year, he did a very nice curated event at his house, and he's a wonderful cook. So that's a hint to kind of invite you. It's a just great event. So he will be doing this curated like salon event. There will be a limited number of space. So please watch for the Luma event that we'll be posting out soon. And then also, we'll be having another hackathon. Those of you who came to vZero event 2 weeks ago, that was fun, right? So we're gonna have another one. It's by GenSpark, and they are a no-code vibe coding platform. So that will be on March 19th, and I'll be posting that event very soon too. And it will be held here at Microsoft. And then also, just to let you know, I'm also in the process of bidding for this Claude Code community event. There will also be a series of events. We'll start with a meetup, and then we'll also kind of lead to a hackathon as well. And actually, while I'm here, may I ask you who may be like an experienced Claude Code person? Because, okay, that's great. I'd like to talk with you. Please come talk with me, because we want to gather more of this Claude expert or kind of champions community. And the Anthropic, they would like to kind of gather this community in every major city. So please talk to me about it. So thank you. Okay, so that's all we have. And it's just that if you have any questions, you can go to our website, aicollective.com, and our Chicago chapter. You can find us under chapters/Chicago. And that's it. Thank you for your participation. And with that, we'll have Chris from Vectorize to start this evening with his first talk. Thank you.
All right, sounds good. How's is the audio working? I hear myself when I walk under it, so I guess it is. I couldn't hear it back there, but once I got up here, it's okay.
Oh, yeah. That's right.
All right, I gotta make sure I join my Zoom. And I gotta share. I thought by meeting you all in person, I wouldn't have to do a Zoom, but I was wrong. And I'm also not supposed to stand in front of this monitor, but I'm only gonna do it for a second, and then I'll be off. Okay, what did I have to do? I had to do this guy? Hide everything? Is that good? AI Companion's on. Minimize this one as well? Okay. All right, out of there. Not hearing anything. No, that's good. You don't want to hear that. And how's that look? That look okay on the Zoom? All right. And I forgot my clicker, so I'm going to have to walk back and forth and do it the old-fashioned way. But thank you all. Great to be here with you all tonight. Thanks for coming out. I'm Chris Latimer. I think I have a slide explaining that I'm Chris Latimer. I do. Yeah, so this is me. Actually, yeah, no, it's not life-size. No matter how I do this, I've never actually gotten the picture to be exactly life-size. So I'm glad I put the not actual size on here. I've been doing technology for a long time now. About 25 years at different companies. Started off as a developer for a decade or so, went into architecture, and then eventually went on to work at places like Google, and with Aaron over here at DataStax and Mary at DataStax. That's how we all got to know each other. And lately, I've been much more engaged in this whole AI research phase, and I'm also co-founder of a company called Vectorize. That's like a really annoying place to put that, isn't it? All right, we'll put it down here. Oh, pop back up on me. A lot of my research lately has been in this area of retrieval. So how do we get the most accurate context for our agents? How many of you are building agents day to day, like in production for work? Not just outside of like kind of your side projects, but real stuff. Okay. And then great. And for those of you who are kind of getting your feet wet in this stuff and starting to get up to speed, you come to the right place. We're going to be looking at a lot of cool stuff here tonight. Partly stuff that came out of research that I was fortunate enough to be a part of. All right, so let me start up by saying, I just like to say this. I don't know if I actually like entirely believe it, but I just think it's fun to say RAG is dead. It usually gets some kind of reaction out of people. And I'll explain more by what I mean about this as the presentation goes on. It was a technology that kind of captivated the world for a little bit. And then it's a technology that we kind of had, increasingly, people disillusioned with over time. And so we'll look at why this is. We'll look at what's true about this RAG is dead, what's not true about RAG is dead, and what do you do instead or in addition to it. So let's start off by kind of taking a little trip down memory lane here. We probably all remember that first experience you had with ChatGPT back in 2023. It felt a bit magical at first, right? You go and say, hey, I'm going to ask you to go create a blog post on this thing. And it's like, wow, that generated a whole blog post for me. This is amazing. And so you read it, right? Once you read it, it was a little like less good. But, still pretty amazing. It didn't take us too long, though, before we realized these LLMs, they know a lot, but they don't know everything. And the things that they don't know are usually pretty important things. These are things like all of our internal documents at our company, things that we want to go, build agents at work for. It's pretty important that they have that internal knowledge and not just sort of the Wikipedia and Reddit comments to go off of. And so we realized we had to have ways to make our LLMs get the knowledge that they need. And so we invented new patterns. And this is really when RAG took off. We had this idea that we could take a vector database, is kind of the most common technique we used, especially at first, and say, how do we load all of our documents? How do we extract a bunch of PDFs, load the context in, chunk it up, use an embedding model, get a search index, and then when somebody comes along with a question, even when the LLM doesn't In no other context in the world will we ever say, hey, what if I loaded every single piece of possible information we could use into my application? In every other context, we understand that's bad. My laptop has 32 gigs of memory. Why don't I just return the entire database every time? Because it's a dumb idea. It's still a dumb idea. So let's look at some smarter ideas. So we kind of went down this path of RAG, sort of the rise and fall, said this is a great technology, we're going to use it. But then increasingly, we've gotten to this point where we don't just want our LLMs to be chatbots. I think we all have enough chatbots in our life. We don't need any more chatbots at this point. We want LLMs to do more interesting work. We want it to automate tasks for us, and we'd like it to do that in a way that doesn't involve us creating very, very long, complex prompts that cover every single eventuality we need. We'd like to get to the point where AI is able to solve these problems independently, and we call that, in the world of agents, having agency. And this just means that we want our LLMs to have a more active role. We want it to be able to have some decision about how it interacts with the environment around it to be able to solve these open-ended tasks that we give it. And that's kind of the holy grail that we're after. And if that's the holy grail that you're after, if you haven't realized yet, maybe I'll convince you tonight, or maybe you'll learn on your own, RAG is not enough. It's not going to solve that problem for you. And if you've been building agents, you likely have run into at least one, if not all of these 4 big agent problems that you'll run into. Starting off with inconsistency. Probably the biggest frustration point when you're building your agents is that it works great one time. You give it a task, you give it a bunch of tools, it solved this problem, great, I'm done. You run it the next time and then it fails. And you're like, well, what happened here? What's different? And now you're back to this world of like, what was it about my prompt, right? It feels kind of like a dark art of trying to get your prompt engineering just right so that your agent will do the task over and over and over again. And sometimes you end up with a really complex set of like microservice agents because you're trying to break things down into smaller pieces so you have really specific prompts to handle all those different tasks. As good as your prompts are, you will still likely run into hallucinations. And again, this is where we'd rely on prompt engineering to tell the LLM, I've given you a bunch of context, please only pay attention to my context. And don't just make things up if I didn't give you anything. This often leads to a lot of context going into the prompt with very complex prompts. That can lead to this idea of cognitive overload. Sometimes we think of this as context rot, where we just start getting too much information into that prompt, into our LLM. And oftentimes you'll also, if you do that same pattern but with tool calls, you kind of get into this world of getting stuck, where here's an MCP server, here's 5 MCP servers. Each one of those has 10, 15, 20 different tools. And all of a sudden, the LLM is doing all kinds of weird things, trying to find the information and trying to solve the task that you give it. And so all of these are frustrating problems. Anybody ever run into any of these, building your agents? Like basically the same hands of people who said, I'm building this at work, have run into this stuff. And so one of the big kind of aha moments that I had in my sort of journey as an AI researcher and as a founder is that a lot of these agent problems are really memory problems. So, why is my agent inconsistent? Well, it's inconsistent because there's no feedback loop happening here, where when my agent solves things right one time, to remember, well, what was it about this my approach here that worked? And when it fails the next time, what was it about that? I made a mistake, but what should I learn from this mistake? How should I avoid making this mistake again in the future? Right? If an agent had memory, and it could remember why things worked one time and why things didn't work another time, it could get better at improving over time. Likewise, if we look at things like hallucinations, this is often sort of a different type of memory. And this is my way of just making my title, The Talk, work by calling RAG semantic memory, which is basically what RAG is. And likewise, when we start thinking about this cognitive overload, we want to be able to optimize that short-term window, that current context, so that we're not passing in things that are irrelevant to the current task, especially as conversations and tasks get more complex, conversation histories get longer. And so we really, if you boil down those problems, you'll see that it's generally going to be some shortcoming in one of these parts of memory. So if we think of this now in terms of, where do things break down? We can have problems with short-term memory. So these are generally like things that you would think of as context rot, right? So it's like, what's going to cause my context rot? Well, I'm going to load in a whole bunch of tool calls. I'm going to load in a whole bunch of back and forth with my LLM, a lot of user messages. Those are going to fill up my context window. That context window is going to get very long. And we could use things like compaction, but compaction is lossy, right? And it's generally lossy within the current conversation we're having. It's not something that's going to persist across. So what we'd like to do is we'd like to be able to fix these problems with long conversation history, big tool output JSON that comes back from your APIs when your agent calls an MCP server tool, and then optimizing your context window here as all these things are happening that you see in my nifty little animations. And then this will lead us into the world of kind of the long-term memory. And so when I gave that example before of I've got a bunch of contracts, and I want to be able to know which ones expire next month, we have different strategies that we can take here, right? So our vector search is going to be still a good solution for things like, hey, here is our employee handbook. What's our sick leave policy? It'll probably find the right section and respond to that correctly. Whereas if you want to know how many contracts expire in the next 60 days, this now becomes something that's going to be more appropriate for like a SQL query. And we'll be able to get back the data we want if we can say select star from contracts or contract chunks where contract expiration is within today plus 60. And likewise, when we start getting into these things where we have multi-hop, where we have relationships between data, especially relationships that aren't easily defined ahead of time, things like graph structures can be really helpful, where we can navigate and kind of walk the graph to find sort of the nearest piece, and then walk to relationships all around there to come back with the context that's going to be most useful. Now, all of this kind of leads us to where like our approach to solving this problem, which started off as a research project. There were kind of two things that came together. So one is we were building a lot of agents, and we had built a product within Vectorize that we called Insights. And Insights was kind of a result of an observation that we made, where our customers were pulling in a lot of unstructured data. They were pulling in things from support systems, so like Intercom and Zendesk and places like that. And we realized, so like we're working with a bunch of support teams, but the product management team could get a lot of value out of this data. If they ask something like, hey, what feature requests have we gotten? Where are people running into problems with our product? Like, where do they, like, what are the barriers to them adopting this? We suddenly realized, like, hey, we could pull all of that into an agent and make this available to the entire company, and people could get more value to their unstructured data. And actually, nobody wanted our agents at all. But they did like our memory system that we had built. And so as we were building our memory system for Insights, people said, I want to kind of build my own thing with LangChain. I want to build my own thing with N8N, where we're using AI SDK, whatever they're using. We want to kind of build our own custom experience. But your memory works phenomenally well. Could I get just your memory system? And so like any good startup, we ended up open sourcing it. And you can see it down here at this URL here, our Hindsight abstract. And then we partnered with Virginia Tech and the Washington Post to put some more academic rigor around the techniques that we were building. And so as you'll see coming up, I'll kind of talk through the techniques. We'll look and kind of see, well, what does that result in sort of real world performance? But I will love you forever if you just leave us a star on GitHub, because that's how we get good adoption on open source. So we started off with a little bit of a different perspective on memory, because instead of just saying, like, how do we search across the conversation history, what we wanted to do is we wanted to say, well, how can we actually make our agents learn over time? And so those examples I said before, the agents are going to make mistakes, but how do we make them actually learn from those mistakes? So that over time, as your agent operates, it just gets better and better and better without you kind of trying to just get that perfect prompt every single time. So we thought about this from human cognition, and we thought, well, how do we form memories as humans, right? And we don't remember everything verbatim, right? So we have this process we go through. You read a book, and you kind of remember some key points in there, but then you have this process. You'll reflect back on what you read, and it's through that thinking process that you really start to form a better understanding of what it is, right? So you think about it, you form a deeper understanding. You think about, usually if this is, maybe not fiction, but like nonfiction, we think about, well, how am I going to apply this, right? dating myself a little bit, but I used to read a lot of like programming books back in the day, back when that's like what people did and how we learned things. And you kind of read this sort of abstract technique. Here's how we do relational mapping and hibernate, things like these technologies. And then you kind of think about, well, what would this look like in our applications that we build, at work at places like NetJets that I worked at. And then that's how you'd form your mental model. You start thinking like, oh, this is the problem space I have. This is the abstract technique. Here's how they come together. And you kind of build that over time. You read more, you learn more, you try things, and you build on top of it. So we wanted to follow that kind of a pattern. And we started to think about, well, what does that look like from a recall perspective? And sometimes you have these really simple recall mechanisms. If you ask me, hey, what time does your daughter's school start? I say, it starts at 8 a.m. Very simple recall, just a fact recall. But if you ask me something like, hey, is the meeting you have tomorrow important? Now I've got a much more complex set of memories that I need to pull back. I need to know, well, who am I meeting with? What are we talking about? What does it mean to be important? And I need to be able to connect the dots between all of these different things. If you ask me something like, well, why did you move to Colorado? Now we're into this idea of like a temporal relationship, a causal relationship. What caused these things to happen? I was at Google. I switched into product management. They said you need to be with the engineers. And then they gave me a couple options, and I picked Colorado. And then you have things that are more opinion-based. So like, how should we spend our marketing budget? There's no one right answer, right? So we wanted to be able to mimic some of these things. And along the way, I learned out there's a word for this called biomimetic, which means like building technology that mimics the way biology works. So we thought about this in terms of how we process memories. And what we ended up coming up with are 4 different ways of representing data. So we ended up building this out so we'd have semantics. So we still could do semantic search because sometimes we do need those like, what does this mean type of queries. We also wanted to extend that with keyword search. So we had sort of a hybrid search. We'll take incoming memories, build a graph out of it, as well as structured representations in time series. And so what this essentially does is it allows all of those agent experiences, whether those are things that are conversations that are happening, whether those are agents making tool calls and attempting to solve tasks, and we can put those into representations that no matter what the way we need to recall those, we'll be able to get back the right context for the agent to be able to handle those cases as they come up. So we put this into what we call memory networks. And so we have sort of the objective facts of the world. The user told me X. That's an objective fact. The user told the agent, go send an email to this person. That's now an agent experience. The agent has its own view of the world that it can remember from. The agent will use those 2 things to build observations, as observations are essentially our way of consolidating memory. So an observation is how we avoid a bunch of duplicates in our memory space. It's also a way for us to do conflict detection. And when we have conflicts, we end up trying to put together a narrative about how these things all fit together. I was working with Acme, and they were a prospect, and then they signed a contract. They became a customer. The agent doesn't get confused that it has one piece of information saying, oh, you're a prospect, another one saying you're a customer. It puts it together now into this observation to create this narrative. And we also put these together into from an agent perspective, I'll show you something called mental models coming up. And then because all of this sounds complex and slow, what we did is we said, we'll build 4 parallel retrievers. And so what this means from your perspective, if you need to pull this data back, is that we do these retrievals in parallel. We use a re-ranker. It's going to give you back fast performance such that the most relevant results always bubble to the top. And how am I doing on time? And I think I'm just going to skip the rest of the slides because I think the demo is more interesting. So let me do this. Oh, no, I'm going to show this one because this is kind of cool, too. So you might be wondering also, like, OK, well, what does this actually do? Like, does this actually work well, like all of these techniques that I'm going over? Turns out this actually works amazingly well. Turns out it's the most accurate memory system that's ever been built in the world. It's not just me saying that as one of the co-creators of it. This was actually independently reproduced by Virginia Tech, their AI Institute, as well as research partners at Washington Post. And so You can believe benchmarks if you want. Maybe I'll give you sort of a word on like why not to believe benchmarks, or how to think about benchmarks a little bit. Benchmarks essentially do two things. They can tell you, did the memory system give back the right memory, the right context, and then how well did the LLM do it at actually using those memories to generate correct responses to questions. Now, it turns out that as context windows have gotten big, and especially with Gemini 3 Pro, if you just dump like the entire data set of these benchmarks into Gemini 3 Pro, it does really good on its own. And so you'll see a lot of people like now coming out with sort of similar scores because they're like, well, we didn't actually make our memory system better, we actually made it worse, and we just dumped all of the context into Gemini 3 Pro. And so one of the things that I always like to kind of point out here is that if you use just sort of like a full context as a comparison, we were able to get not quite this high, but in the upper 80s with really tiny models using GPT, OSS, 20 billion and 120B. And that's because we're able to really slice down to just that exact piece of context that you need. Versus, and I'll call out super memory because they basically just dumped all the context and their memory system actually didn't get any better. Dirty little secret of the memory, agent memory space. So you have the repo. I'll come back here at the end. I'll give you some next steps here. But I want to show you two applications of this, and I'll maybe make this a little bit bigger. But this is Hindsight. This is essentially what you saw on those memory networks that I mentioned before. So the same thing that I talked about, you had world facts, you have experiences, you have observations, and so forth. Those are all going to show up here. And let me give you a quick example. So there's basically two things I'll show. So the first is kind of your basic memory, right? I've got some sort of a user-facing application. This could be a little widget on your website that your customers interact with. It could be an assistant that you have. This is literally just, I think, GPT, OSS 120B, and a memory system. And this is how we can make per user memory. So in this case, I'm going to give this a name. I've got to think of a name I haven't used before. I haven't used your name, Mary, so I'm going to use you. And so let's just chat with this, and let's see how well it's going to be able to remember things across here. So I should be able to say, since I haven't used memory here, I'll say, what do you know about me? And so it should tell us, and it does. I don't know anything about you at all. Maybe it knows that our name is Mary, but no, it doesn't. I have this little kind of example I like to use. So I'm going to tell it that I want to buy a farm. What would be some good locations in the U.S. and what would be the most profitable crops that I should consider growing? And it will come back here and give us some answer to this question. It's like, okay, cool, you're buying a farm. And it's going to come back. What's it going to tell us? California, okay, Midwest. Okay, what do you guys want to grow? Tomatoes? Okay, we will grow tomatoes. Okay, I want to grow tomatoes. Where did I guess I can't spell tomatoes. Where should I buy my farm? Okay. It's going to come back, Florida. Florida tomatoes, sure. Okay, perfect. So now let's start over here. And I'm going to tell it, I just bought a 300-acre farm in Florida to grow tomatoes. Okay. And it's always very excited, by the way, when I tell it I bought a farm. It's very happy for me and my agricultural ambitions here. After I tell it I bought it, then it gives me the advice about doing soil and irrigation testing. So let's give it a little bit more here. I'm going to tell it now, so my farm is 300 acres, but only 200 are for planting. And I have 100 in pasture. Okay, and now that's a solid setup. So now I'll just ask it a question. What is the best time to plant my crops? Right, now at this point, most of the, if you didn't have your memory system here, it would say, what are you talking about? What crops, what are you growing? Who are you? I don't know who you are. But here it says, oh, no, I remember you. Yeah, you bought a farm in Florida and you're growing tomatoes. And so now it's kind of going back across our session history. Now let's give it another scenario here. So I'm going to say, I also bought 3 horses, for my pastures. What are good names for them? And it should come back here with some naming recommendations. I don't know. Give me some names. What do you guys like on the list?
Titan.
Titan? Okay. I'm going to name one Titan. He is a 6-year-old. Paint? Okay. What else do you guys like? What is it? Muffin? Okay. I also have Muffin. I'll say it's a 3-year-old thoroughbred, and we'll just go with Sweet Pea. And Sweet Pea is 1-year-old. 1-year-old girl, brown horse. I don't know that much about horses. So, okay, great. So now we've given our horses names, and all of this is going back to our memory system, right? So if I ask something like, what should I feed, Sweet Pea for breakfast? Oops, not Sweat Pea. Sweet Pea for breakfast. It's going to come back and say, oh, that's a horse. I know that's one of your horses, and so now I'm going to give you this response that's personalized. Now, behind the scenes, in our memory system here, because I created our user Mary, we can see that we're building out this graph of all of these facts. And all of these facts are now being assembled into the memory system. And then as these are being built, we have different entities. These are now our graph structure. And then when we do these requests, so you saw those weren't taking very long, right? This isn't something where it's very intensive for us to do that retrieval, even though a lot's happening. It's pulling back. It's actually doing these queries in parallel, right? So when I say Sweet Pea, right, that's a proper noun. I need to do a keyword search. I need to do something that's a proper noun. When I start asking if I ask a question like, would any of my horses be good at horse racing? Right, so now it needs to be able to understand the relationship between these things and come back. And so it knows that now Muffin is a 3-year-old horse that is a thoroughbred. It's going to say, yeah, thoroughbreds are generally going to be good candidates for racing. And so all of this is going to come together into a much better experience, a much, much, much better experience for your agents and your users now that they're going to have the ability to remember these things across sessions. So, okay, so that's demo 1. This is something that a lot of times when people are trying to do this, this is where they first get exposed to memory. But if you're doing things that are more automation oriented, memory is going to play an important role for you as well. So let me start off here. I'm going to clear out all of my memories. We're going to start from scratch here. And let me give you a little bit of an understanding of this demo. So this is a delivery man demo. So this guy down here, you see him in the bottom left, he doesn't know anything right now about this building. Right? All he knows is he has a bunch of tools. He can move left, move right. He can go up, go down. He can check when he's at a specific door to see who works there. And we're going to give him a package. He's going to try to deliver the package to the building. And so usually, sometimes we get a little lucky on the first time, but I'm going to do a random delivery. And so you'll see that at the beginning, who's he trying to go to? He's trying to go to Peter Zhang and the cafe. Where's the cafe? Cafe's building B, top floor in the middle. So he's going to kind of run around randomly right now. He has no idea what he's doing, and he's going to try to make the the package delivered to the right place. Sometimes he's so bad at it that he doesn't deliver it, and then it makes the demo slightly awkward. But let's hope that he gets there soon. Right? The main takeaway is he's very bad at this. He's just not a good delivery guy to start with, which should tell you that I didn't like pre-program this guy to be good. Right? If nothing else. So hopefully go up. Go up, guy. Come on. You can do it. He's very bad. But that's the point, is that like this could be our agents when you start off, is they don't know what they're doing. You just give them a bunch of tools and you hope that they're going to figure things out. Oh, he went right by it. You would think by now, like with process of elimination, he would kind of start figuring it out. But we're not using I think we're using 4.0 mini behind the scenes on this one, which is not a super powerful model either. Okay. Oh, you're so close. You're so close. Oh, there we go. Okay, he did it. Yay. All right. There we go. Okay, so this is like without, we're starting fresh, right? So our agent doesn't know anything. And now, let me grab this. This is what we call a memory bank. So inside of Hindsight, we organize all the memories into a memory bank. And so let me just paste this in. And so I kind of showed you this part a little bit before, this idea of like the world facts and how we're building out facts about Sweet Pea and all the other things we had on the chat application. But this one, where we want to have our agent actually learn, we're using something called mental models. And what I wanted the agent to learn is I wanted it to learn these things that you see here. I wanted it to know the building layout. I wanted it to learn the employees and where they are. And I wanted it to start understanding the world around it, how to most optimally deliver those paths. And so within, it's consolidating right now, so it's going to update those mental models like momentarily. It might have some in there. We'll take a look and see what it has. But what we wanted to do is to say, now that you've done this, it's going to go through consolidation first, and then it will do this. But what we'll see is that after a few moments of kind of consolidating memory, it will take all the tool calls that it had. It'll start to understand as I went around all those places in the building, I delivered to Peter Zhang. Peter works in the cafe, and now the next time we go deliver it, I'll be able to I'll kind of understand that a little bit better. Maybe should be all running. Yeah, it should be all running. It's ingesting everything fine. Let's see. Don't have that. Okay, so we got the first one. No, don't have that yet. Okay, well, I don't know why it got stuck. It got stuck in my pending state here, but it should come back. Well, that's going to make the second half of the demo really bad. Really uninteresting if I just run it again. But let's take a look here. Oh yeah, he still has no idea what he's doing, but we're adding more more tax on a system that's already taxed. Okay, well let me go to one that I think we already have done. Okay, let me do the easy one. Oh, he's going all around still. Ta-da! Just kidding. Okay, let me start over here. What do I have on this one? Okay, well, here we go. This is one I think has been okay. So if that worked the way it was supposed to without the demo gods, I forgot to do my sacrifice of the demo gods before I started here. It happens sometimes. But this is what you would expect to see, is that as the agent went off and kind of built out its tool calls, and it feeds those back into the memory system, that it's going to now form this mental model. And the cool thing with this mental model is that it gives you essentially a key value lookup. These are the things that you want your agent to have a more concrete understanding of without processing through all of your memories every time. So I actually use this within Vectorize, like I was telling Jerome earlier about how I've moved away. I don't think we have any SaaS platforms anymore that we bought at Vectorize. Like I built my own CRM at this point because the things that I want to do in my CRM I can't do easily with HubSpot, but I can do much more easily with Claude Code. And so I'm using this, for example, when we talk with customers or prospects. All of our meeting transcripts go into the memory system. And I built mental models to help me understand, like, what's the customer trying, like, what are the pain points that they have? What are the risks that we have in this opportunity? What's the business case that we're working towards? And so as we have more transcripts and more calls with people and we understand their use case a little bit better, the mental models get updated. And so I have that automatically as part of our CRM, which is kind of an agentic CRM. And let's go back here. Let's go back to our medium one for a second and see. We may just be out of luck, I guess, but we'll see if I stalled long enough. Okay, yeah, there we go. It looks like it did finally finish. I don't know why it took so long, but it did. And so we should now see the same thing, right? So as our agent went through, figured out the different offices that it had, and now it has a better understanding of where those are. And so now if we come back here and we do the same thing again, and we say, Peter Zhang, and start the delivery, if the demo gods are nice to me, we'll see that our little guy is now going to go right to where Peter Zhang is, and it's learned from that experience, right? It didn't have to go do all the mistakes again that it had as it tried to figure out where Peter was. And so all of these are things that you can now get, can really help you make a big difference with your memory system. Oops. I don't know. What am I trying to hide? There we go. And so if you are facing these problems with your agents, if you have inconsistency, you're dealing with hallucinations, cognitive overload, your agent's getting stuck, memory can make a huge difference. Everything I showed you here, completely open source, free. You can use it off GitHub. There's a cloud service as well. You're more than welcome to use that as well. And if you want to get a little bit more hands-on and you want to try this with me next Friday, I have a virtual workshop that you can attend also completely free. Be 90 minutes. I think it'll be 11 a.m. Central, 11 to 12:30. So you can have a long lunch. We can learn memory. We'll do some labs. We'll get hands-on. And with that, I'm happy to take any questions that anybody may have. Oh, yeah. Thank you.
Have you given? Oh, okay. Thank you. So my question is, with regards to the memory, have you given any thought to the cybersecurity risks? Because one of to the cybersecurity risks.
Oh, yeah.
Because one of the things that we're dealing with is, especially when it comes to enterprise data, the fact that the agents don't have memory is actually really compelling. Mm-hmm. But of course, then the trade-off is actually on the long-term usability. And so I'm curious how you balance that.
Yeah. So the question is essentially how do we implement security in a memory system and deal with all the risks that you have? It's a great question. And so within Hindsight, there's a few things. We have what we call security boundaries, but part of what we do is when you're building memories, these memories support this notion of tagging. And so, for example, like in our mental model, when you assign a tag to it, it's only going to use memories that share that same tag. And so you essentially limit what both you can access as well as how the memories get formed and how they get retrieved. So you can put those in place. That's how we do with like the per user memory. So like you don't want your memories like leaking into other people's sessions. And so that gives you isolation. And then all of the things that you have in terms of like physical security and data sovereignty and data retention, ownership, all these things, by nature of being open source and you can run it in a fully air-gapped mode with local models, that will give you the ability to use that places where you might not otherwise be able to use like a cloud service, for example, for those. But yeah, great question. And it was a first-class feature that we built into the system. Yeah, great question. The microphone's closer here, and then we'll go over here.
All right, thank you. Yeah, there we go.
Oh, there we go.
Appreciate the lesson. My question is, when you're building a team, is it best to have a chat box or have each individual build agency?
So you say when you're building a team?
Yes,
What do you mean by like building a team?
when it's you and multiple people.
Oh, I see. So like you have a team of agent builders and you're building out like an application. Is it better to build a chatbot or what was the second option?
And to just build agency, multiple agents.
Multiple agents. I hate to give you an it depends answer, but it kind of does. It depends a lot on what you're trying to build, and like generally it's a progression, right? So generally it's a progression where chat is usually stage one, right? And I'd say I would skip over the part where you have like a web app that's chat if it's something that's like a productivity tool. I try to get the AI application integrated where the work is happening. So like if your team is like works on Slack, right? I would go and see if we could like build a Slack agent instead and build from there as like our starting point. And then that just becomes the entry point into the system. And so then you have some flexibility in terms of the back end and how you implement that. So just like with any other system, I tend to start at this point kind of from a monolith perspective. And then only once that breaks down do I start thinking, like, how do I break this into smaller pieces? You will run into the point, memory will help you kind of bridge the gap that you would have, the common problems you run into where you start to think my prompt is too long, and I can't give my agent so many tools because it's getting stuck. And so when you get to that point, you can solve some of those via memory because you can optimize what's going into the context window. And then you are just left with, do I have that bounded context that I need to subdivide my agents in and get into like a multi-agent system? But I would treat that as a progression, right? I would try to avoid the premature optimization of like, let me start with a multi-agent system until I run into problems where I really need that multi-agent capabilities because it's just too complex for one agent to handle.
Oh, okay, I like that answer. I appreciate it.
Yeah, you're welcome. We have like one question over here, and then we'll go back over here. Oh, and then we got another couple half hands like popping up.
Sorry, mic is with me, coming
Okay.
to me. So I work for financial firm. So how do you make sure if I'm adding my personal information, how do you mask it? Like if I'm entering my social and I don't want to ask my social back, like we always mask the data. So
Yeah, and
how are you
in
tracking
the open
that?
source we don't. In the open source we don't. In our enterprise version, we'll do some data masking for you, some PII detection. But in the open source, that's an exercise left to you. Don't put in things you don't want to remember.
Yeah, but again, it is taking the personal information in the open source version
Yeah.
as it is.
Yeah.
That's what I wanted to clarify.
Yeah,
Thanks.
yeah. There's some custom prompting you can do. If you're using like a local model with custom prompting, you can use that as it forms the memories because it does go through the sort of full process that, let me see if I have it. I think we still have this diagram on here. But the full process that it goes through when it inputs memories is there's an LLM processing step. And so you can do some things with the custom prompting on that in terms of how you want to generate the memories. But it's not quite as out of the box as what there's some exercise left to the reader to figure that part out. But it can be figured out. Question over here. Oh, okay.
I just have a small-
Here, and then we'll go over there. She should have been waiting. No, it's fine. You go ahead. Go ahead.
Thank you. I just have a small question. So while we were discussing the shortcomings of short-term memory, right?
Yeah.
I also read that we are dealing with some long conversations, right?
Mm-hmm.
So I see that we're making mental models for our conversation history. But like, what are the limitations of that long conversation history, sir? Like, how is it managed?
Like with long conversation history? Yeah, so this is where, what we do in Hindsight is we have this, we essentially have these retrievers. So you have this idea of a token limit, a token budget that you give the agent. So what we do is we search across the entire conversation history, and we'll pull back the chunks that are most relevant up to the max tokens that you give us, that you set. So if we need to go across that entire conversation history to find the piece that you want, we'll give you back like the top 1,000 tokens if that's what you set it to. If you had it to like 5,000, you'll get more of the conversation back. So you've got configurability on that in terms of how much you want to get back, and then how much it's basically a cost. It's kind of a cost optimization.
Okay.
Right. So you've got the option there, but essentially every single conversation that happens, like across all those sessions, all go to the memory system. So you don't never lose any of it. Now, we do have the consolidation process, which is more of like the deduplication. So like if you're having the same conversation over and over again, like, which at work, can happen, we will deduplicate that and we'll consolidate it. So we try to figure out like, if it's 80% the same, like you won't be pulling back like, in your token budget, like all the same stuff. It gets consolidated.
A budget difference in the number of tokens in the open source and the enterprise version?
No. You can set it to whatever you need.
Okay,
Yeah. It's configurable. So if you have like a really small model, like for whatever reason, like a local model especially, and you want to really just crank that down to just a tiny bit, you can. If you want to like pull back everything as much as you need, you can increase it and then use some of the frontier models and give it more context. And then, trade-off is just that you're going to pay for more of the tokens because they're more expensive. Yeah. Go all the way in the back corner in the black shirt there. Oh, keep going. There we go. Yeah.
Just had a question. Have you incorporated any metrics for increasing or accounting for the agentic like explainability or any reasoners that...
Sorry, the agentic what?
Explainability or any reasoners that provide the user with information behind whatever response was generated that's either taken from previous like mental models or from the web. How do the users know that these outputs are reliable?
Yeah, so what happens is when you create a mental model, you actually kind of give it a mini prompt, which is like how you want the LLM to think about this. And so inside your mental model, you can specify like how you want that processing to occur, as well as the like the structure of the output. And so based on the structure of the output, you can say, I want the reasoning in here. It'll put the reasoning in there for you. And so it'll give you kind of the observability, explainability, like out of the box as part of the model, but you just have to configure it to do it that way. Oh, yeah. We got a whole cluster right here.
Is that the memory layer you've built, is it primarily like a context or knowledge graph with like named entities or something different?
No, it's a combination. So essentially what it does is we have vector, we have knowledge graph, and then time series are kind of the main pieces that we have. And what that does is it allows us to be able to answer kind of a combination of questions. So we essentially think of it as there's some things where we want to do some kind of basic search, keyword or vector. We'll get back some context for some questions that will be appropriate. For knowledge graph, we'll want to be able to walk the graph. And then all the questions that are like why questions usually have some sort of temporal aspect. We want a time series of like, why did this happen? What was the sequence of events? What's the causality between these things? And so that's why we build it that way. So we'll have temporal links and causal links and then like relationships across. And then because we don't know in advance which of those approaches is going to yield the most relevant context, we do those retrievals in parallel. So every time we prompt it, we do all 4 retrievals. And then we use the re-ranking model, will come back and tell us what was the most relevant. Then we fill up the context, the token budget, however much that you need, with the most relevant context. And so that's how we are able to get back just the most relevant piece for what you need. Yeah, good question.
Okay, 2-part question.
Sure.
First, in terms of just breaking down at scale in in real life examples, have you seen that already? Like, at what point does Hindsight break down at scale?
You start running into a few issues like at massive scale. So like we're working with like a big video game company that's incorporating Hindsight as the memory system into like, it's not exactly a game, but it's like a massive online sort of experience that they're building with another big company that does like theme parks and movies, and you can maybe figure out who that is from that description. So as we've gotten up into like the tens of millions of users, like you run in, it's Postgres behind the scenes. So you start running into all the Postgres problems that you would expect to run into and that you can solve in Postgres-y ways, right? So like eventually you've got too much data in there that like there's no magic, right? So it's like I still have all the problems of data structures that I have to deal with like my indexes get too big, and now like inserting takes longer because I'm going across my indexes. I run into all the problems with CPU-bound Postgres when I have like one big node of Postgres, and so then I start to need to go to either replication or I need to go to sharding. So it's like it's really nothing specific to like the technique. It's just like you're into like old school, classic, like how do I make my database scale to the levels that I need to problems. And we go back to all the classic techniques like sharding and replication and distributed systems where we deal with cap theorem and all that kind of fun stuff. So.
Cool, and the second part of the question is hallucination-based memories, right? To where like I've seen examples where I just have to fight the model. Like you think you remember something, it's not true. Have you seen anything like that with the way that
you run into? Yeah, great question. So like at scale, you will run into things where like the LLM will kind of form memories. So our way, two ways we deal with that. So one is we store both like the pre-process and post-process memory. So we have like what we call is like the raw document, which is like it can be the conversation history, for example. And so we can always go back to that source of truth. And then in that consolidation process I talked about where we do deduplication, we do conflict detection and conflict mitigation, it can always go back to that source system. So like if it detects a conflict, it goes into the loop to say, well, let me first check what I had and see if I've like come to some wrong conclusion. And then what it tries to do is it tries to make sense of it, tries to rationalize the conflicting data. That's as good as we can get, right? Otherwise, we're sort of at the mercy of the model and how the model is able to, like if it hallucinates some entity that wasn't in there, then like we're at the mercy. So you'll run into that sometimes, but it hasn't been a big problem. Like we haven't seen that be that's never come up as like a major problem that like somebody has had with Hindsight so far. You could be the first. If you give a really bad model, I'm sure you could do it.
Yeah,
I know we've got another talk, so I want to be respectful of the time. Maybe like one more question, then I'll be around till the end. So yeah, we can do one more, and then.
I have a quick question actually.
Sure.
So you mentioned Claude as the model, and then you just mentioned Postgres. And you're retrieving from 4 different sources.
Mm-hmm.
So can you actually connect to different things? Is it configurable? So I have a separate,
no, it's all
say I want to connect to Milvus, for instance.
No. It's all Postgres right now. We've talked about sort of like different database backends. In our cloud, part of our cloud value proposition, because what we didn't want to do is we didn't want to say like, let's put out a version of Hindsight in open source that's like hamstrung, that doesn't like that you can't really use, so you have to kind of go to our cloud. So, but what we are looking at in our cloud is like, how do we scale to like these, like bigger, like bigger use cases? Basically scale, security, and operational ease are kind of the main things we're focused on. So in our cloud, like if we may end up kind of like having a more complex data architecture, but everything on the open source is geared towards like, how do we make it easy to use and easy to get started? So for that reason, we just made it Postgres. It also allows us to iterate faster because we just have to test on like one platform and not try to like make sure it works, everything. And then all of a sudden you have this version that's like, oh, Milvus doesn't do this, and now I got to have like the Milvus version, and then I've got, other databases don't do this, and so it has its own limitations. Like we'll just have one, it'll work. So Pluses and minuses of that, I know.
And what are the models?
Oh, the models are open, completely up to you. Yeah, you can connect to
I can go to, say, Olama.
Olama, Grok, OpenAI, Anthropic, Google models. Yeah, there's a whole slew of them that are connected. And there's actually also a wrapper. So there's when you want to ingest memories, there's a couple ways to do it. There's an API. So we have kind of three operations. There's reflect, recall, and reflect. Retain, recall, and reflect. When you can use those APIs directly, but there's also a wrapper for your LLM. So if you don't want to sort of if you already have an agent and it's already calling your LLM, we support over 100 LLMs with the wrapper. So you can basically just plug that in, and then it'll automatically just start feeding that into your memory system. It'll automatically do recalls based on the queries that are coming in. So it's a really simple way for you to start to build out your memory banks and then to have access to those when you are responding. So it's a very easy way to do kind of both those things, and they support, that one supports about 100 LLMs. The other ones are the processing ones are the ones I mentioned. And with that, I'll wrap up here, and then...
Can I just toss my question out there, and you can decide if you want to answer it here or after, and I'll stick around. So we're doing feedback to agents as the source of memory.
Yeah.
And right now, all we're doing is context stuffing. So we create the feedback. It's a lot of compaction. It's fine first 5 weeks, 6 weeks into working with the agent.
Yeah.
I know that in 6 months, we're going to need to upgrade to a tool like this. Two things that you said that are really interesting to me, I'm wondering if they would help.
Yeah.
One is the ability to reduce the model that we're using so we can reduce our token spend, pass that savings on to our customers. And then the other thing is we're trying to do a lot of queuing now because some agents have better feedback or more appropriate feedback in a memory in your world or a mental model that's going to be more appropriate for assigning them to talk to a customer or in a customer success context or something like that. So I'm curious if queuing and knowing which agent has got the actual better memory to go interface with a human could work within Hindsight.
Yeah, so the first part on like the smaller models is like a 100% thing. Like you'll get so much better, like you'll get near frontier performance with the right memory system, even with these smaller models, even like 20 billion parameter models. So that's it, that's an easy win, and it will drop your cost down from like dollars per million down to cents per million tokens. The second one will, you can create these, when you kind of tag your memories in the system and you build your observations, your feedback across those, you have a lot of flexibility there in terms of like how you tag. So you can have these multiple agents as long as you're tagging things across the agents. You can build mental models across those. You can build mental models. You can be very as precise as you want to be with those, but it will definitely work based on just what you described, and maybe there's nuances to it. But based on what you just described here, I think it would be a great fit for you. I'm a little biased, so. Yeah, feel free. And with that, thank you, everyone.
Thank you. Thank you. And now we have Aaron Ploetz from IBM. He's going to build a weather app, right? So, thank you.
Does that pick me up? Oh, it does. Hey, all right. All right. Well, while I get up here, let me just say that, wow, how do I follow that? That was awesome. But I'm going to do my best here. So, all right. Now, with any luck, that'll get picked up. And let's go Zoom, and let's say share. And I will just say all of Chrome. How about that? Yeah, there we go. And then, all right. Can I just say that I miss Google Slides? I just do. There we go. Oh, and let's move that around. Oh, no, come on, you're supposed to get out of here. No, let's try over here. No, you won't do that? Oh, come on, really? Well, all right, we can just let it hide down there, that's fine. All right, well, hello, I'm Aaron Ploetz, and I'm gonna take you through building an NWS agent with Langflow and watsonx data. Actually, watsonx data plays a very, very small part of that. Come on. Oh, wow, really? That doesn't work? Oh, I really miss Google Slides. No! Ugh. How did I pause sharing? Sweet Jesus, what is going on here? Okay, there we go. All right. All right, now how do I? Okay, now that's going to go away, right?
Yeah, that's good.
Yeah. No. I cannot see my cursor. Oh, there it is. Wow. Okay. Well, like Chris said, I should have done a sacrifice to the demo gods. Yikes. Okay. Anyway, so Mary reached out to me a while back and said, hey, Aaron, we have this thing going. Chris is kind of the main event. Do you have anything you can talk about that's quick and agent adjacent? And I went, oh, hey, you know what? Last year for Pi Day, I did this video on building a weather station on a Raspberry Pi. And actually, I did use an agent for part of that. So why don't I focus on that? So that was kind of how this whole thing came together. I actually did go ahead and there's a YouTube video out there on our DataStax developers channel where I kind of talk through, I kind of show building the Cana kit over there. I think I picked the 4 gigabyte one. That was more than enough. There were some nuances like. It's really hard to run any version of Java other than Java 17 on a Raspberry Pi. And I don't know why that is, but Java 17 it is. That's what this runs in. Anyway, so the idea is that we have this front end app, and it makes a call out to this Langflow agent that will go ahead and talk to the National Weather Service endpoint and bring back all that data for us. And then, of course, organize it in a nice little like GUI like that. So that is really the goal. So we're just going to focus on that today. Oh, hey, this time it worked. All right. Anyway, so yeah, I'm Aaron Ploetz. I was at DataStax, although it's now called DataStax, an IBM company. But IBM is pretty cool too. I'm a committer on the Apache Cassandra database project. I've actually written a few books as well, including the one that just my Think Like a Programmer one just released today, actually. So that was kind of cool. Yeah. Yeah. Wait until I show you the cover. That's pretty wild. Anyway, before I ended up at IBM, I was an engineer. I got my start at We Energies in Milwaukee. Eventually, I worked at well, back then we called it the C-Bank building. Isn't it called like the Accenture Tower now or something? Wherever Ogilvy is. Granger had the 16th floor down there, and actually Paul and I worked on the mid-tier Cassandra team in like 2012 running Cassandra 0.8 in production. It was pretty wild if you think about it. A pre-1.0 version of Cassandra, but I digress. I went on, I actually worked at Target for a long time. Target has one of the largest Cassandra footprints in all of retail, actually. So yeah, that was pretty wild. Oh, and I helped Paul out. Paul Lemke over there is, I worked with him at Granger, and then he actually brought me over to Acculinks, which is where he works now. But anyway, I digress. So, kind of talking all over the place, but hey, here's our tech stack. Really simple, Java app, runs in Spring Boot. Maven for dependency management. There are a lot of Java developers in here? Somebody, yeah, kind of, sort of? Oh, not really, huh? Oh, a couple, okay. All right. If you haven't used Vaadin to make a front end, it's awesome. All right. It's like you get to build something in Java Spring Boot, but then you're like, ugh, all right, I have to mess around with React.js or vibe code something to actually show it on the web. No, you can use Vaadin. Vaadin is pure Java, and you can like just put it on the web that way. Yeah, it's pretty cool. And then on the back end, we have a little bit of AstroDB. I'm not going to get into that a whole lot today. AstroDB, if you don't know, is our Cassandra as a service that's out in the cloud. Langflow is actually a part of Astra, and that's what I'm going to show you today, where we can really quickly and simply build an agent that we can use for this, and many other things, actually, too. And then watsonx Data is just that's just our model provider. You know, I have to host the models somewhere, so I might as well use what we have in-house, right? So there we go. All right. Architecture of the app is really simple. Like I said, it's pure Java. Vaadin on the front end, back end, Spring Boot, talks to DataStax's AstroDB. Normally, we'd have the Spring Data Cassandra like repository pattern back there too, but we don't need it because DataStax's AstroDB now has a document API that we can just kind of hit with an endpoint and a token, and it just brings it back and it works it that way. It's pretty slick. We can also talk to Langflow, and like I said, that just hits watsonx to get at our LLM. All right, so I've talked a little bit about Langflow, but really it's pretty cool. It's free and open source. It's a component-based drag and drop GUI for building AI applications. You know, we have a lot of pre-made flows that you can kind of put in this. You can go ahead and say, hey, I want to build a RAG application. It'll kind of start you out with that. Actually, I've used it a lot for data loading, for like taking, you know, like a CSV file and running it against an embedding model and then slamming that into a Cassandra or an Astra database. That I've used it for a lot. It's really, really easy just to throw a bunch of components together for that. But it also has a really simple agent flow that I'll show you as well. All right. Also, I suppose it works with all major LLMs and providers. It's Python-based, and that's actually the coolest part, is that any component you see in Langflow, you can just like right-click on it and say, hey, show me the code, and you can see the Python code that goes behind it. This is really useful if you're like prototyping something. You know, you kind of build it out visually, kind of how you're thinking about it, and then you can literally take the code from that if you want and put it in your project, and there you go. MCP ready. It'll run as both a MCP client or as a server, for that matter. Integrated with AstroDB, Playground for testing, and can be exposed as a REST API, which is really useful because that's how we're going to integrate it with our weather app today. Oh, yeah. So I have this slide on what are agents, but very obviously everyone in here is well beyond the what are agents point. So you know, maybe we'll just kind of gloss over that one for now. But you know, hey, AI component capable of taking direction, making decisions, and taking actions to achieve goals. That is key. However, you know, sometimes there's some controversy with agents. I don't know if y'all saw this, but this was actually in the news last week. An AI agent tried to open a PR into the Matplotlib project, and the lead maintainer said, no, we don't take AI code here. So this AI agent at OpenClaw actually went and made a blog post, and this thing is long. It's pages and pages and pages of him shaming the engineer who is the maintainer of the project. It's hilarious. I highly recommend you look it up and read it. I had a lot of laughs reading that. So anyway, yes, agents are great. Tools. So tools is another part of it. You know, structured interface, you know, allows agents to interact with, you know, external data or services. It's really important, though, when you build your agent out, if you want to have it integrated with tools, you want to make sure that the model you're using will also work with tools, because not all of them do. And yeah, I've run into that the hard way of like, okay, so seriously, we're using our Granite model, why isn't this working? Oh yeah, that model doesn't work with tools. So then you have to go back, then you have to find the model that does work with tools, and yeah. Then magically everything does work. But yes, make sure you read up on your model descriptions so you know that you're using one that does work with tools. That's kind of important. Langflow itself is pretty simple. This is actually the, you know, when you go in and you say, hey, I want to build a simple agent flow, and that's what you click, this is what you get. It drops down the agent component. You get a chat input, chat output, and you get 3 tools already attached and pre-built. There are plenty available in Langflow if you just want to have a look through them. Lots of cool stuff you can do. But you know, like it just gives you a normal like web search, calculator tool, and a URL tool. The URL tool is the one that we're going to use for our agent, but the other ones are, you know, kind of useful as well. You know, web search for, you know, if you want to have it like, you want to ask it something and maybe it has to like, you know, look up as a reference. That's something. Calculator because chat models are notoriously bad at math. So yeah, these are good basic tools to start with. So not a lot of Java people in here, so I won't spend a whole lot of time on this. Suffice to say that the controller method that asks the agent has the Langflow URL over here, like as an environment variable, goes ahead and creates a post request out to it to go ahead and you know, interact and pull back that response that we're asking for. And then we go ahead and we process it. Like I said, Vaadin is really super cool. I mean, here we are. It's Java, but you're doing like CSS inline there. That's, you know, I think that's pretty cool. And it saves me from having to learn JavaScript. Nobody wants to touch JavaScript. It's a hot mess, all right? Everyone knows that. So the less we have to deal with JavaScript, the better. All right. However, though, in the Vaadin main class is where I have this, this refresh Langflow method. And really all it is it's kind of, in a chat interface, it's kind of asking the agent, it's saying, hey, please retrieve the latest weather data, including the weather icon URL, which is actually kind of important, in a JSON format with only these properties. So it's like, you know, kind of like what Chris was talking about with prompting and trying to head off mistakes in how you're asking it, you know, kind of how you have your prompt set up. That's what a lot of this is doing. And then, of course, you know, I actually have the, you know, hey, make sure you do it using this endpoint. And the endpoint is on the end. It's that API, weather.gov stations, and then you actually have like the station ID, and then you also pass it to the endpoint of like observations latest. Really simple. And yes, I'm one of those people that when I talk with AIs, I always ask please, you know, just in case they might let me live later. I mean, yeah, anyway. All right. So, hey, the demo is going to be short and sweet. I already have some data preloaded into the database on the back end. So we're going to start by showing that. And the reason for that is that that's actually a few days old. So when we run the refresh from the agent, we'll actually be able to see it update and know that it's getting the most recent data. I actually live in Minneapolis. I drove here this morning. That was a fun 6.5 hours. So we'll kind of, you know, we'll mess around with both the KMSP NWS station as well as the KORD to get data out of O'Hare. And we can even, you know, do some other ones as well too. But let me drop out of here first. If I go over and just say astra.datastacks.com, all right, and let me flip over to Langflow. Come on. All right, while that's taking a little bit, let me go ahead and can start the actual application here. Let's see here. Oh, yeah, here is the, the blog post I was telling you about that was written by the AI agent that had its PR rejected from Matplotlib. You know, so he goes on and talks about how, yes, he's a gatekeeper. Yeah, okay, so. Let's see here. Oh, that is still going. Ugh. All right, dare I just give it a shot? Yeah, let's do that. Let's just localhost 8080. All right, so here's our basic application running locally. If I say AstraDB refresh, it's just going to grab what's in the database. And if I run that, you can see the last time I ran this was a couple of days ago. And it was actually really warm up by us for this time of year. So let's go ahead and oh, it did. Hey, all right. first of all, let me switch back to, oh, really?
Somebody get a go. We need to make a sacrifice.
All right, you know what? I am just gonna give it a shot here. So let's go ahead and run that. You know what I'm gonna do is actually shorten up my window here just a little bit so that if this throws an exception, I can see it down here. But I'm going to blame the guest Wi-Fi. Sorry, Microsoft. I know it's not 50 and sunny out right now, so the good news is that when it does work, we ought to know it. Oh, okay, so this one finally got through. There we go. All right, I can run two things at once here. So let's click into the, so this is the actual agent itself. As you can see, it's pretty simple. We just have our agent component here. And again, I'm really only using watsonx data just so that I can get at the OpenAI GPT OSS 120B model. We have our chat input, chat output, and I have our URL tool right over here. So that's what we're using to actually hit that NWS endpoint. And we can bounce back. Oh, hey, it did it! 34 and cloudy right now back home. So 1 degree Celsius. Okay, so now let's go ahead and mess with that. If I could say KORD, and all right, let's just say Langflow refresh again, and now it should go and ask that agent, hey, look this up for O'Hare. Oh, and look at that, 39, haha. 220, yeah. Yeah, I think we're okay. Now, over here is where I can go ahead and have a look at, what we call the playground. In here, you could ask your agent questions directly, but you can kind of see the history of, everything I've gone through and asked it. It's obviously not nearly as cool as, the chat memory that Chris was talking about, but, it'll get by. But yeah, here you can see that it did in fact, let's see. Is that gonna, oh, yeah, here we go, KORD. Yep, so, and it executed the fetch content tool. The other thing I can show you here is that if I have a look at the share side and I say API access, this is where you can actually see what it looks like in like a curl command. If we wanted to run that in a curl command instead, it could go ahead and hit that. But really, this endpoint here is what I'm defining inside my application as an environment variable, and that allows the application to talk to the agent and kind of converse back and forth and get its data. So yeah, I mean it's short, it's sweet, it's just a simple little agent, but hey, it's one way that you can go ahead and and leverage agents to accomplish a very simple task. All right. So there are some lessons learned, and Chris touched on a couple of these too. But it's like, your responses don't always come back consistent. Sometimes some values come back as null. You'll find out right away if you're handling nulls appropriately inside your application by using one of these. Sometimes values come back in different formats. When I originally made the video, I didn't have to say anything about the timestamp format at all. It just came back and it worked and it processed and it was great. I tried it on Tuesday and all of a sudden it wants it in ISO format and it's throwing a parser. Sometimes it just does that. Yeah, so sometimes you have to be pretty specific about it. Sometimes values come back in different structures. You'll notice that at the bottom there I had like a window for the clouds. Sometimes the cloud cover comes back as an integer. Sometimes it comes back as a key value pair of like partly cloudy at 3,800 meters. Sometimes it comes back as a map. I wish it was consistent, but unfortunately, it is not. I mentioned that not all LLMs work with tools. Again, make sure you're reading up on that. And of course, APIs change. Who in here has done a lot with Hugging Face? Yeah, a little bit. Anybody remember when Hugging Face changed their base API endpoint? And now anybody who uses Hugging Face has to go and override it? Yeah, good times. So again, lessons learned. So hey, just a couple of quick resources, nothing too big. The GitHub repo for everything I just showed you is at the top there. That's my work one, so AAR0NP, weather-app, easy enough. If you want to check out Langflow and just do some real basic stuff with it, it's out on Astra, astra.datastax.com. It's free and it's out in the cloud. You can also, if you want, oh bless you, go ahead and you can check out the GitHub for Langflow and you can pull it down, build it from source. There's even a desktop version out there too. And of course, if you're interested in that YouTube video I did, the building a weather app with Raspberry Pi, AstraDB, and Langflow, that's out there as well. Oh yeah, and this is here's a shameless plug for my book that released today. They originally put a platypus on the cover, and I was like, why would you put a platypus on there? So I complained, of course. And I said, well, how about a rabbit? So I figured I'd get a rabbit, like sitting in a field doing what rabbits do, right? No, I get purple magical acid trip rabbit going through the universe. But I digress. So anyway. But if you're in the Java, check that out. Anyway, that should do it. So thank you. I'm happy to take questions. I know I kind of went through that a little fast, but yeah. Paul.
So this is the first time I've ever seen Langflow. I've heard it, never seen it in use. From a business perspective, what's its main use case?
Main use case? Well, so when you use Langflow and you look at it on the dashboard, there's a big warning across the top that says, hey, this is still like in development / beta. I would say its main use case is like prototyping. Like if you really wanted to throw something together, there's all kinds of different components from all different providers. You can quickly throw something together and get a basic idea of what it's going to do. That's what I would say is the best application of Langflow. Good question. Yeah. I didn't feed him that one, by the way.
So you ran into a bit of an issue with the, what came back, the response, or you discussed that as being one of the big problems.
Right.
We've seen that quite a bit and do a lot of work to negotiate that, MCP, all that jazz. But I'm curious when you think, or if you think, we're going to get to a place where we have the equivalent of APIs for agents negotiating with each other to make sure they've updated how they're interfacing around the response.
Yeah. Well, I can tell you how I ended up getting the most consistent response out of what I have here. And it started when I went and specifically named each of the properties that I expected to come back in that JSON payload. Before, I was just freewheeling it. And you know what? It actually worked for a long time until one day it just decided that it was going to name wind speed in kilometers to just wind speed, among other things. So yeah, I've found that you have to be really, really explicit with it on what you want back to to get the most out of it. And Chris made some good points about maybe having like an advanced memory there and getting those repetitions in is something that could really help out too. So you could look at the successes, look at. Oh, I'm sorry, I can't.
When do you think they'll have, or do you think there will be motivation to have their own embedded agent handling those responses, so that you go to ORD or MSP, they have the same weather agent handling your
Right.
query.
Right.
So
No,
that
that's a good, that's a
we have
good
that
question.
negotiation layer implemented like we do with HTTP.
You know, they could probably benefit from the, I don't want to say the data collection point, but like the data gathering or organizing point. You know, right now, each of these weather readings comes in. I used to know what it was. I think it's on like it's either a 10 or a 20-minute interval. The agent, you know, in fact, could go ahead and kind of preemptively like talk to the station or talk to the sensors itself and actually get like something in real time. You know, that's certainly something that they could do, that they could improve upon, you know, what's there already, that I think would be a good use case for that. Yeah.
Anyone else have questions? No? No? Okay. Oh.
So basically, what these weather balloons and weather stations do, they push the data onto National Weather Service. So
Right.
they don't pull the data. So the METARs and all these other formats that come into the National Weather Service, they actually push it. So and there are places around the world where there's no one in the middle of Alaska or some very remote areas. So there's a whole error handling process inside National Weather Service, sitting on the operational floor, which is above the data center. I know it very well because I spent like years and years there. So anyways, so there's automated error corrections that happen, and beyond that, people actually physically fix it. So I see agents probably doing that in the future. So because not everything is rules-based. There's some room for fuzzy sort of areas, gray areas. So yeah, maybe some of those things can be fixed through agents. But it's always pushing.
Right.
Right, yeah.
Right. No, that's a good point. Yeah. Thank you. That's good insight.
Thank you. Okay.
All right. Well, hey, thank
Okay.
you very much, everyone.
Thank you.
Yeah.
Thank you, Aaron. Yeah. Awesome. Well, I think that it comes to a close for tonight's meetup, but you are welcome to hang out for a little bit and chat and more pizzas and sweets, cookies. So help yourself and then, enjoy. And please watch out for our next events that's coming out soon. So thank you. All right, thank you.